We saw with function overloading that the same function name can be used to take different types as parameters. To make this process more streamlined, by eliminating the need to write the same function multiple times, C++ provides the ability to create a template function that can process different data types and which can be generated at compile time, that is when you click the Run button. Here's an example for defining and calling a function template. So let's define our function template of type name T, and we're closing the arrow brackets. Then we define our function with T instead of the data type. Let's say we wanted to add two numbers, so add of T in place of the data type X and T Y. Open curly braces, and we're going to return X plus Y. So let's see this template function in action. I want to add two numbers, and these numbers are going to be integers. So add, I have to declare what the data type is going to be, and input my parameters 8 and 1. I'm going to add a new line so that when it prints nicely. So this is how I can call the template function that is going to accept integer values and is going to return an integer value. Let's say I wanted to call this template function for doubles. I can call add and then declare that it's a double and then pass in decimal values. If I run that, I can see that the template function executed for both integer values and double values. So that's how we can declare template functions. There's a couple of things that we should note here. One is that template is a reserved expression, is a reserved keyword, and that indicates that the function here is a template. T is a template argument that indicates that the function accepts different data types. So wherever T appears, it's a placeholder for the data type. And what's actually happening is that during compile time, the compiler checks all the calls to the add function and creates a version of the function for each data type. So the compiler will create an add function for ints, and it will create another add function for double. So effectively what it's doing is that it will automatically generate int add of int x and int y, and then we'll input the function, and then so it detected that for int, and it creates the int version of the add function, and it will also do the same thing for double. So the compiler detects that there's an add function that will accept data type double, and so it constructs that automatically. So it will create add double x and double y, and then return x plus y. Now, it's a little bit more involved if we were to define these things up front. Templates really helps to reduce the size of the code, makes things easier to maintain and debug and process.